so today, guys, we are covering system of equations. Okay. I'm going to tell you the way I'm showing you for the systems part, where you actually have equal signs. This is the worst part. I disagree with showing this at all, but it's part of our course, so we have to have it so you know what to do for the test at the end of the year. Okay? It's called solving system of equations by graph. So if I gave you y equals 3, okay, and y equals 2x minus 3 plus 1.
You set them equal to each other, don't you?
That's if we were doing solving a system of equations, and I am going to show you that today, but our goal today is using graphing to do so. Okay, so what I have to do is graph both of these. So this first one up here I'm going to do in blue. Does anybody know what the y equals 3 graph looks like? The horizontal line. Because it has to go through the y-axis at 3, but notice it is not rising or running. Does that make sense to everyone? I want to get out your notes and put that away. So that is the equation. And that's what it looks like, right? Now we get to remember how to graph absolute values as well today. Can anybody tell me what does the x minus 3 do to our graph? Marco?
So it's just the x to the right.
Right 3.
Wait, isn't that in vertex form?
It is already, kind of.
Yeah.
So it's right 3,
So plus 1. Right.
and then plus 1, so we shifted up 1. So it's right there. Is everybody okay with that? Remember when we did charts? You guys remember when we did charts? When we graphed this? I'm not going to have you guys do charts today. I'm just going to, now let's pick a number to the right and to the left. What's a nice number to the right?
2.
Okay, that'd be to the left, so we can pick 2.
You can't go
2 minus 3. Negative 1. Absolute value of negative 1. 1. 1 times 2. 2 plus 1. So at 2, I'm at 3. Let's notice, what do we also know about absolute values that are very similar to quadratics? They are, anyone? Euler? They're symmetrical. Aren't they symmetrical? A V is the same symmetrical as a U, right? Make sense to everyone? Okay, so therefore, notice how I went 1 unit to the left, and I'm up here at 3. So if I go 1 unit to the right, I should be up here at 3, correct? Does everybody see that? Okay. Now notice, I want to pick some more points to get a better accurate graph. So I'm going to pick, let's pick, that was 4. You notice, I'm starting to just show you. 4 minus 3 is 1. Absolute value of 1 is 1. 1 times 2 is 2. 2 plus 1 is 3. Still works, right? Let's pick another value. What's another value you guys want to pick? 4? We already picked 4.
7.
Okay, 7. 7. 7 minus 3? 4. 4 absolute value. 4. 4 times 2. 8 plus 1, 9. So it's right there. So notice that is 1, 2, 3, 4 units away from the vertex, correct? So I'm going to use 4 units. 1, 2, 3, 4, and I should also be at 9. So notice, ladies and gentlemen, there is my graph. Hey, where do these two guys intersect? That's the goal, is where do they intersect?
2, 3, and like 5.
4, 3, and
4, 3.
2, 3. Now what's wrong with this? Why is this not a very accurate way? What if I'm not graphing exactly?
Then your answer will be off.
It's going to be off a little bit, right? Let me show you how we can use our calculator. I don't remember how many of you guys have this calculator. So far I'm seeing 3, 4.
I did it.
Okay? So, if you have that calculator, get it out. 5. There we go. Okay? So I'm going to pull up my calculator here, my Wabbit. Okay? So I go on. I have to turn it on. Okay, and then I hit my y equals button. You guys should look like this. You might have stuff in there, but if you do, that's all right. Okay, so what I'm going to do is I'm going to do y equals 3. So I just put a 3 there. And then my second equation, I do y equals 2. And then it's absolute value, so I'm going to go math over to num. And ABS is absolute value. Your guys' might not go to the absolute value bars. Yours might still say ABS, right? Hey, hey! How are you? Tell me your name again. Sierra, do you not get to drawing today? I just know I've had you for a while. Wow, look at all these three just pop in. So I thought you were still in the class. Do you want to drive today?
Sure.
Do you want to drive today?
No.
No? Why?
I can't. Oh wait.
We're at. Go get it out of Foster. Burger King.
Oh, you're the world. Jeez.
Foxtrot over and out. We'll be back shortly after
You
this
want it?
break.
Yeah,
Those math students out there,
Well, I got to
keep
drop her
trucking.
off before.
Mr. Roberts is only here to help you. Just general life advice. The lowest tanning bed level you can go to and actually get a tan is level 3. So that's also good information to know. As for other things, I just say, just be true to who you are. But don't be nice, because nice people don't ever make any money. Except Oprah. She's freaking nice.
Okay. So it all fits.
Carlos, spicy biscuit.
I'm trying to hopefully do it today, tomorrow, Thursday, Friday. You guys are done on Friday. Oh, jeez. Is that pause already? Pause. Over to num and then the ABS.
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 Not to be confused.
Oh, I didn't even know that.
I'll set it in
So
mind.
I'm here at the y equals. So now I obviously want to put what is in the y equals.
It's weird.
What's in the y equals? This is the x button, minus 3. And then notice I want to push out, and that was a +1, wasn't it? Was that what it was?
Yes. Yeah.
And now, guys, I'm gonna hit zoom 6 so that we're all looking at the same one. There's y equals 3.
It grabbed it for you? Wait, what did you push?
Wait, zoom what? No, we just go down to 6.
Zoom 6, yeah.
And like 6 pictures of
So there's the graph.
mine didn't work.
That's cool.
Okay. So
Oh, yeah, this one is super
But it's witchcraft.
Okay, I'm gonna do something, because this is actually not yours anyway. Nope, it's good now. It'll be good now, 'cause I reset it.
What? Carlos spicy.
That's good. I'm sorry.
okay, so if you graph this, and that's basically what our graph looked like anyway, right? Let's show you how you can also find the intersection. Okay? So I'd go second, calc. You guys see the calc button up here? And then notice number 5 is the intersection. I push over to where it gets close to it, right here.
You can hit
Hit
trace.
Enter. Nope, trace is not accurate.
Make sure.
Hit enter, and then it says to guess. My cursor's right where I think it is, and notice 2, 3. Where it is.
Well, hang on. You click yes or this?
No, let's show you again. So notice I want to find this guy right here. So I go second, calculate, number 5. I push over until I get where I want to be, roughly right there. Fine.
Okay.
I hit enter. Now it says the second curve. Now notice, guys, do you see how I'm on the absolute value now?
Oh my goodness!
So I hit enter, and then it says to guess. I'm really close to where I want to be, right? So I just hit enter. And fourthly, showing where it's intersecting. Huh?
Witchcraft.
Witchcraft, huh?
Yeah.
And that's the intersection. Yeah, that's really what we're doing today. So you can check your work as well using your calculator. But if you just use the machine, I will just mark you wrong. If there's no way that I can see what you're doing, I will mark you wrong. Okay? Does that make sense? Everybody there with me? No problem. So for me, anytime I hit y equals, anytime you want to graph, you go to y equals. Okay, now absolute value, just to let you know, when you put it in your equation, this button right here is the x value. Okay, where to find absolute value is in math, over to numbers. We have that also in the trace function. Notice you can scroll down. We have the least common multiple. So like, if you ever want to see that, let's show you what least common multiple is. That's what you could use for greatest common factor. So least common multiple.
Why was I shown this in second grade?
Comma, because you don't need it. 3 and 9.
Until later in your life, it's like a 401k, like not telling a kid about me 20 and telling him about me like 65. Guess what? Social Security is going to be around when we're 65. We're completely run out Social Security by the time I'm 65. So
opt out of it right now.
that's what I'm saying. But I'll get in trouble if I don't pay it now.
You can opt out. Your employer will opt out for you.
And if I'm employing myself, that'll
Then
work.
you can opt out. You just have to pay an extra fee. Oops, record. So 2 equals 2, x minus 3. Now what? Divide by 2. So 1 equals x minus 3 in absolute value. Now what? Nope, we can't do that yet. We got to set it into our two equations, right? Because what distance gives me a value of 1? 1 and negative 1, right? Does that make sense to everyone? I add the 3. Oops. Plus 3. X equals 4. Wasn't that what we had earlier? Was x equals 4? And then add the 3. You want me to go up? Is that what you're saying? Add the 3. X equals 2. Isn't that the two places where our graph intersected? Was that 4 and 2? And what's the y value? Well, for us, the y value was already given to us. What is it? 3. Well, what if it was like 2x minus 5? What would you have to do? You'd have to go plug them back in to find the y value that correlates with that, right? Does that make sense to everyone? Notice, what did I just do? I showed you graphically. I will scroll down just a second. And I did it mathematically, algebraically, right? Oops, sorry. Right here. You guys remember when we started and it had extraneous solutions, meaning we solved for it, but it didn't work, correct? Let's try to do one of those, okay? So if I had y equals x plus 2, absolute value minus 1. Let's see what that looks like. All right, let's go ahead and solve this by graphing. So we're going to graph it first. Can somebody tell me where would be the x value of my vertex? Of the absolute value. It'd be negative 2. Does everybody see the negative 2? Where would be my y value of my vertex? So right there. Does everybody understand that? How do I graph this now? I pick a point to the right, I pick a point to the left, and I go at it. Does that make sense? Let's pick a point to the right. 1. Negative 1. Negative 1 plus 2. 1. Absolute value, well, yeah. 1, absolute value 1 is 1, 1 minus 1 is 0. If I plug in 0, 0 plus 2 is 2, absolute value of 2 is 2, 2 minus 1 is. You guys see why I always get frustrated when you guys don't do anything for a graph? All you gotta do is pick points, guys. Pick them. If you don't see a shape that we all know this should look like a V, right?
Right.
If you're not seeing your V, start picking the points the opposite way. You get what I'm saying? Just toss it on my ground. You see trash can around here? Okay, so basically we're seeing this already. Does everybody see that? Now we could use symmetry and notice 1 over would be 0 and 2 over would be 1. And there's that graph of the absolute value. Does anybody have any question on how I got that? Okay, now we gotta graph the bottom. Where is he at? Start at -4, right, Marco? I think I heard you say.
Oh yeah, because I guess y equals -3, right?
And I go up 3 over 1. Up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. How many times does it cross this time? Once. But, now watch when I do the math for this guy, watch what happens, okay? So that's what our picture is. And then we'll graph it at the end and see if our answers make sense, okay? Is that, everybody okay with that? All right, so once again, A equals B and B equals C, what do we know? X plus 2 in absolute values minus 1 equals 3x minus 4. Is the absolute values by themselves? No, they're not. So what do I have to do? Add the 1 over. If I add the one that's a minus, yeah. Okay, so then what do I do, guys? You guys remember? Set it equal to its positive and set it equal to its negative, right? You guys remember that? Okay, I'm going to scroll down a little bit. So x plus 2 equals 3x minus 3, and x plus 2 equals negative 3x plus 3. Y'all see that? Okay, let's go ahead and solve. I'm personally going to add the 3x here and subtract the 2, so therefore I have 4x equals 1, x equals 4. Okay, notice guys, here's 1, a 4. Do I intersect at a 4? Yes or no? I don't, do I? So guess what? I'm not even going to plug him in because my graph doesn't dictate that. Hence why a graph can help us in our solutions as well. You guys see what I'm saying about that? You guys see how it doesn't intersect at x is a 4? Guess where it actually intersects? If this guy continues on, see how it intersects at a 4th there? That's why it has that solution. But,
Lines are kind of sad.
I know that. But you get the idea.
Only meet once.
Is everybody okay? Now let's go over here. So I subtract the x, add the 3, 5 equals 2x. Now what? Divide by 2. X is 5 halves. Or 2.5. Here's 2.5, roughly, right?
Oh,
That
nice.
makes sense, doesn't it?
Nice.
Does that make sense to you?
I think so.
Can you guys see by looking at our graph, we can say what solution actually works and what makes sense? You get where I'm going at? Okay, so now I have x equals 5 halves. Am I done? What do I need to do? I need to plug it back in to this equation here or here. Doesn't matter which one. What would you guys rather do, the 3 or the top? I'm going to go ahead and do the 3x minus 4. There's a little less work there. Gentlemen, please. So, 3x minus 4, that was the equation, right? So y equals 3, 5 halves minus 4?
Yeah.
How many of you guys want to play with that fraction?
I mean, if no one else wants to play with it, it's like always good to make new friends that don't have to.
Anyway, so I'm going to times by 2 to everything. And what this does is now I have 2y, because that 2 cancels out, equals 15 minus 8. That's a little easier, isn't it? Could you guys do that?
Probably.
Sorry, I'll scroll up again.
See, I'm just look right there. Play with that kid.
So where, ladies and gentlemen, did we intersect? 5 halves, comma, 7 halves, right? That's where we intersected. You guys see that? The 7?
Oh, wait, never mind.
Let's go down there. 15 minus 8 is the
Okay.
7. Okay, so now let's go to our calculator. Okay, so let's go up here. Y equals, I gotta turn it on again. Y equals So where do I need to go first? The math button, over to absolute value. What goes in it? X plus 2 minus 1. And what goes on the bottom one? 3x minus 4. Go ahead and grab. There's our absolute value. There's the line. Okay. Notice, guys, let me show you something else. If you ever plug that in, it can help you graph as well. Look at this. Second table. Here's the graph of the absolute value. If you plugged in 1, you get 1. If you plugged in, 0, you get 1. 1, you get 2. If I push up, notice it still gives me value. Here's the, if I plug in -3 into this graph, watch, -3. What's -3 times -3? I mean 3. -9, what's -9 minus 4? -13. How do you get there? So I was here, well, I was in the graph button, right? So see the table, and just hit second graph. That's another way you could help yourself graph, right? Might be off just a little bit. Anyway.
Oh, I figured it out.
Okay. So let's go ahead and find the intersection to make sure our answer makes sense. So what are we going to do? We're going to find the intersection, correct? How I did that was the second trace button. I push over to where I believe it is. Hit enter. Second curve, I'm pretty close to it as well. And then I get it. 2.5, isn't that 5 halves? Yeah. 3.5, isn't that 7 halves? That is. So you can check your work as well. Okay. Notice, guys, there are some times, and let's be honest, is my graph that accurate? Does it make sense that our answer is what it is, but is it accurate? Could you guys find that out very well? That's why graphing is the least accurate way to solve a system of equations. Okay? Is everybody with me there? Okay. What I'd like to do now is I have y is greater than or equal to, was it x plus 2 minus 1? Is that what our last graph was? Yeah. And then y is less than or equal to 3x minus 4. We've already seen the graph. It's over here. Basically, right, you guys have already seen the graph, and then 3x minus 4, 1, 2, 3, 4, rise 3, run 1, rise 3, 1, 2, 3, run 1. Okay, there's our graph. But this time we have inequalities. So when we have inequalities, what does that mean we have to do? We have to shade. Okay? All right. So with absolute value, the absolute value one's always pretty easy. Okay, here's my vertex. Do I go above or below? Danny, what does that say? Y is greater than or y is less than? Okay, so does that tell me above or below? If it's greater than, we go above. So, ladies and gentlemen, the top guy is in here. Does everybody understand that? But when we have a system of inequalities, we look for where they share, correct? Okay, so now we got to find out where this guy goes. So, less than, is that to the left or to the right? I always struggle with that. Hence, I remember Harley is like, well, I don't understand what you do, forget it. So I remember, I've showed you guys this.
You pick 0,
pick
0.
a point, and I like to pick 0, 0. So is 0 less than or equal to 3 times 0? 0, 0 minus 4 is negative 4. Is that a true or false question? False. So then therefore I shade on the other side. Where do those guys share? This part right here. Yeah. So that's the part that you shade in very much so. That's the answer. The orange is your answer. Okay? Guys, that's our lesson in a nutshell. You want to try it? Okay, please work.